For the main board of the amplifier, I started by cutting a piece of copper clad, which I then cleaned with steel wool to remove the rust, and with alcohol to take out any grease and other residues. I already had designed the PCB layout using KiCad, and then printed it on a white glossy paper with a laser printer. So I placed the PCB on top of the paper, making sure the borders were aligned with each other in order to bend the paper in place. Then I heated up the iron and rubbed it all over the surface of the paper. After cleaning the excess paper with a nail and fixing some spots with a permanent marker, it was ready for the ferric chloride. The copper parts that weren't covered dissolved in the acid, leaving the copper traces intact. Since it was looking good, I proceeded by making all the holes in the board. The components are the TDA7377 amplifier IC, 1047 and 10 microfarads electrolytic capacitors, 2.47 microfarads film capacitors, a 100 nanofarad ceramic capacitor, an LM7805 5-volt regulator, a 10 kilo ohm resistor, and some screw terminals. The heatsink I use is this old CPU cooler, which I cut down and drill a hole in it to be able to mount it to the main IC. For the Bluetooth part, I utilized this VHM-314 B2.0 module which features 5.0 Bluetooth connection and some other useful features. I removed the micro USB connector in order to attach the power cables, as well as solder the wires to the audio output. I also removed its CMD LEDs to use some external ones later. In addition to the Bluetooth audio input, I also wanted to have a wired input. For that, I used these audio jacks that feature two normally closed insulated switches. This will be coming handy to act as an automatic switch between the Bluetooth and the wire input connection. I designed the enclosure in Fusion 360 to be printed in two parts: the front and bottom piece, and the back and upper piece, in which I tried a technique I never used before. I printed with two colors in the first layer to achieve this nice looking silk string at the back. When placing the thread inserts, I used a small flat heatsink to make them flush with the plastic. Thanks for watching, hope you enjoyed the video, and I will see you in the next one.